Hello, how's it going? My name is Allan Hipolito, and I resolve now the 200 problem called the number of islands. So this is a very much famous problem in LeetCode. It's a great problem that I will use a TFS approach here to improve the performance using a big O annotation of depending of m and n row and calls, alright, in space and in time complexity. So first of all, I will dive into the problem here. The problem wants a number of islands of this grid here. For example, I use this grid here that your return output has a tree. So basically, what the DFS will do here? Basically, we'll add a count every time that you found a 1. And if I found a 1 one time, and the second time this don't will add again. So to avoid to occur this problem, we'll need to use DFS here. So I will pass this to the FS, the row 0 call 0, and here verify 0 1 and 1 0, and here there don't exist. It's important that is in that case the importance we verify to don't occur an error on the code. And so basically continue. So basically we have a 1 here and a 1 here, and we will define these values to 0 to don't add twice. Alright, so and this one recursively we'll call it, and we'll define to 0 here and to 0 and the bottom. Alright, and this guy will call it also. So define 0 already 0, and in the end all these lands here are 0 and the count is 1. Alright, so the 4 will continue here. So alright, I go to here, he's a 0 0 0 0 0, he's a 0 0 at here. Alright, we found another island. So where do you found this island? He's not defined before has 0 because it's a new island. So you count DFS, and DFS you will define this 1 to 0. So this 1 is 0, and here is our also is 0 0 0 0, and the 4 will continues to 0 0 0 0. Alright, another island here. So this island we call DFS, and we'll call here on the right and define this guy to 0. Alright, we return output 3. Let's go to the code right now. Alright, let's continue. So I'll define the row and call here. The row is define a land grid, and the call is land grid at position 0. Alright, so the first I will do our loop here and the row, and in the call also. And if a grid in position E, R, and C is different of 0, I will add in island variable I'll create for 0 here. I increase it by 1, and I will call the DFS function here. So I'll pass the row and call here, and at the final I will return the non-island. Alright, so I will define the method DFS here, passing R and C. Alright, so the first one, we need to verify the edge cases and verify if a grid in the RC is different of 0, right? Actually is a 0, so if this grid in RC is 0, we'll generate and continue the method. So basically we'll define if R is less than 0 or R is more equal to rho, or C is less than 0, or C is greater than call, or grid at position R and C is equal 0. In this case here, I will return nothing. And here, passing this conditional, I will define a grid R and C has 0, right? And I will call DFS and R more 1, and call DFS again in R plus 1, call again C plus 1 and C minus 1. Alright, so I think it's good. Alright, I will run this code to verify. Alright, of ident. Okay, run again. Alright, completed. The case 1, the output is 1, and the case 2, output is 3. Alright, thanks for watching. Bye bye.